Assalamualaikum to all the panels and viewers. I am Nur Aidura binti Azauddin, student ID 2022745751. I am supervised by Madam Nur Fariza binti Abdurrahman, and today I am going to discuss my viva, which is titled Extraction of Phenolic Compounds from Lemongrass Leaves using Natural Deep Eutectic Solvent NADES. This is lemongrass leaves, a versatile biomass, and this is NADES, Natural Deep Eutectic Solvent, a green solvent. NADES are eco-friendly solvents that are made of natural compounds composed of a hydrogen bond acceptor HBA like choline chloride that accepts hydrogen bonds, and a hydrogen bond donor HBD like glycerol that donates hydrogen bonds. This presentation will explore how NADES efficiently extract valuable phenolic compounds from lemongrass leaves, focusing on optimizing the extraction process for maximum yield and effectiveness. Problem statement. This study highlights NADES as a green alternative to hazardous conventional organic solvents. NADES, made from natural biodegradable components, offer a safer, more sustainable extraction method, minimizing environmental impact and aligning with green chemistry principles. The second problem statement is, this study seeks to address the problem of inefficient extraction of phenolic compounds from lemongrass leaves using NADES. Optimizing extraction conditions is crucial to maximize yield, reduce resource wastage, and improve overall efficiency, making the process more viable for industrial applications. The objectives. The first objective of this study is to determine the effect of experimental parameters like material to solvent ratio, time, and temperature on the extraction of phenolic compounds from lemongrass leaves using NADES. The second objective is to compare the differences in the amount of TPC extracted from lemongrass leaves using a conventional organic solvent and NADES. The significance of this study. This research promotes the use of environmentally friendly solvents like NADES, which are made from natural and biodegradable compounds, to reduce the environmental impact of chemical extraction processes. It encourages the utilization of biomass waste, such as lemongrass leaves, turning agricultural byproducts into valuable resources for phenolic compounds. By determining the best extraction conditions, the study aims to enhance the efficiency of the extraction process, maximizing yield and minimizing resource usage, thus making the process more sustainable and economically viable. Literature review. The table compares 3 studies using NADES for extracting phenolic compounds from different sources. Maimulyanti et al. Used coffee husk with optimal conditions of 80 degrees Celsius for 30 minutes and a solvent to material ratio of 110, yielding 10.07 mg gallic acid per gram of TPC. Hu et al. Used Chuanxianghonghua at 50 degrees Celsius for 67 minutes with a ratio of 1:8, yielding 14 mg gallic acid equivalent per gram of TPC. Milosevic et al. Used strawberry tree fruit at 56 degrees Celsius for 180 minutes with a ratio of 120, yielding 12.56 mg gallic acid equivalent per gram of TPC. These studies highlight NADES as an effective eco-friendly solvent for extracting phenolic compounds from various plant materials. Moving on to the methodology, the first step for the method is to prepare the standard gallic acid solutions, and then the lemongrass leaves sample were washed, dried, and ground to get the sample. And then the sample was extracted using NADES of 1:2 ascorbic acid choline chloride ratio at the listed above parameters. In total, there were 15 extractions done for this part. The phenolic compounds in the extracted sample was then determined using Follin-Ciocalto method and UV visible spectroscopy at 765 nanometer. As for the methanol extraction, the sample was first prepared and then the sample was extracted using methanol at 30 minutes, 1:10 ratio, and room temperature. The phenolic compound in the extracted sample was then determined using Follin-Ciocalto method and UV visible spectroscopy at 765 nanometer. Moving on to the results, here is the graph of standard gallic acid calibration curve, and the coefficient of determination R-square value obtained from the graph is 0.9944, indicates a strong fit of the data points to the line of best fit. The effect of temperature. The effect of temperature on phenolic compounds extraction from lemongrass leaves using NADES is shown in Figure 4. The TPC yield increased as the temperature rose from 25 to 45 degrees Celsius and then decreased at 55 to 65 degrees Celsius. The highest extraction yield was at 45 degrees Celsius temperature. The low TPC at 25 and 35 degrees Celsius might be due to lower temperature that slows down the solvent's ability to break down sample. The higher temperatures generally increase solubility, but too high a temperature can degrade phenolic compounds. Studies on various plants show optimal extraction temperatures vary, proving higher temperature do not always yield more phenolic compounds. The effect of varying extraction time on phenolic compounds from lemongrass leaves is shown in Figure 5. The TPC values initially dropped at 10 to 20 minutes, likely due to insufficient interaction time for the solvents to fully extract the phenolic compounds. The values then peaked at 30 minutes, then decreased by 40 to 50 minutes. Longer extraction times often degrade bioactive substances, making 30 minutes optimal for extracting phenolic compounds from lemongrass using NADES. Other studies also found that extended extraction times can lead to the decomposition of polyphenols and other compounds. Figure 6 illustrates the effect of material to solvent ratio on phenolic compound extraction from lemongrass leaves. As the ratio varied from 110 to 130, TPC values decreased, with 110 yielding the highest TPC and 130 the lowest. A smaller volume difference between the sample and solvent enhances extraction efficiency by improving solute distribution and solvent contact. However, higher difference between solvent and material can lead to saturation, which then cause reducing yield. Comparative extraction of phenolic compounds from lemongrass leaves using both NADES and organic solvent. In this study, methanol and NADES were compared for extracting phenolic compounds from lemongrass leaves. Figure 8 illustrates that NADES extraction yielded a significantly higher TPC value compared to methanol, with around double the amount of TPC produced compared to methanol. NADES might have had better contact with the sample compared to methanol when extracting phenolic compounds, due to their unique properties such as their ability to form hydrogen bonds and their higher viscosity, which can enhance the interaction and penetration into biomass matrix. In conclusion, this study optimized phenolic compound extraction from lemongrass leaves using NADES, which achieve optimal conditions at 30 minutes, 45 degrees Celsius, and a 110 material to solvent ratio. NADES also proved to be significantly more effective than methanol, which only yielded half the amount of TPC produced by NADES. As for the recommendations, using response surface methodology RSM is recommended to optimize extraction parameters for higher yields. Additionally, ultrasonic assisted extraction UAE, which uses high-frequency waves, can enhance solvent penetration, reduce extraction time, and preserve heat-sensitive phenolic compounds. Here are the references that was used for this presentation. Thank you and Assalamualaikum.